For centuries, humanity has gazed up at the night sky, mesmerized by the stars and wondering if we are alone in the universe. Among all the celestial bodies orbiting our sun, one planet has always captured our imagination, the mysterious, red-hued world of Mars. Mars, named after the Roman god of war, has symbolized mystery and wonder for generations. From early astronomers like Galileo, who first observed its shifting surface, to science fiction authors like H.G. Wells, who envisioned it as home to alien civilizations, Mars has consistently been at the frontier of human curiosity. Today, more than ever, Mars represents something far greater, the next giant leap for humankind. Why Mars? As our closest planetary neighbour, Mars presents the most viable option for interplanetary exploration and perhaps one day colonization. Unlike the Moon, Mars has a thin atmosphere and evidence of ancient rivers and lakes, suggesting it may have once harboured life. Our quest to explore Mars is not just about visiting another world, it's about answering fundamental questions about our place in the universe and ultimately ensuring the survival of our species. This documentary will take you on a journey through time and space, from the early dreams of reaching Mars to the scientific breakthroughs that are making it a reality. We'll explore the challenges we must overcome, the cutting-edge technology that will get us there, and the visionaries leading the way. Today's documentary is humanity's next great adventure, our mission to Mars. Long before humanity could dream of reaching the stars, Mars was already a subject of intense fascination. Ancient civilizations, from the Babylonians to the Greeks, charted their movements across the sky. It wasn't until the 17th century, with the invention of the telescope, that we began to see Mars as more than just a wandering star. Galileo Galilei, the father of modern astronomy, was among the first to observe Mars through a telescope, noting its phases and surface features, a glimpse into the mysteries that lay beyond. As telescopes improved, so did our imaginations. In the late 19th century, Italian astronomer Giovanni Schiaparelli observed what he believed were canali, channels on Mars's surface. These observations fueled wild speculations, leading American astronomer Percival Lowell to popularize the idea of an advanced Martian civilization constructing canals to distribute water across their dying planet. This notion of intelligent life on Mars captured the public's imagination, inspiring a wave of science fiction, most famously H.G. Wells' The War of the Worlds, a tale of Martian invasion that reflected both our fears and our fascination with the Red Planet. The 1960s marked a new era in Mars exploration, one that transitioned from speculation to direct observation. NASA's Mariner missions were the first to successfully fly by and orbit Mars, sending back images that revealed a world both familiar and alien. The Viking missions in the 1970s were even more groundbreaking, with landers touching down on the Martian surface, conducting experiments in search of life and capturing the first high-resolution images of Mars' dusty plains and rocky outcrops. Mariner Viking and later the Pathfinder mission in the 1990s provided crucial data that shaped our understanding of Mars as a dynamic planet with a complex history, one that may have once supported life. These early successes paved the way for the sophisticated rovers and orbiters that followed, each building on the legacy of discovery initiated by these trailblazing missions. Among the key figures who championed Mars exploration, Carl Sagan stands out as one of the most iconic. An astronomer, cosmologist, and tireless advocate for space exploration, Sagan was instrumental in shaping the public's understanding of the cosmos. He played a critical role in the Viking missions, particularly in the search for extraterrestrial life. Carl Sagan said, "The surface of Mars is the closest we will come to setting foot on another planet in our lifetimes." Fast forward to the 21st century and a new visionary has taken up the mantle of Mars exploration. Elon Musk, CEO of SpaceX, has set his sights on making humanity a multi-planetary species, with Mars as the ultimate destination. Musk's ambitious plan involves building a fleet of reusable rockets to transport people and cargo to Mars, with the goal of establishing a self-sustaining colony. Elon Musk says, "If life is to be a multi-planetary species, then we need to understand Mars. It's the only planet we can realistically reach and terraform in the foreseeable future." But behind every successful Mars mission is a team of dedicated scientists and engineers working tirelessly to overcome the challenges of exploring a distant world. NASA's team has been at the forefront of this endeavour, from designing the rovers that traverse Mars's surface to planning the next manned missions. Their work not only advances our understanding of Mars, but also pushes the boundaries of what's possible in space exploration. Mars, our planetary neighbour, is a world both familiar and alien. Its reddish hue, visible even to the naked eye, has inspired curiosity for centuries. But what lies beneath the surface? Mars is a cold desert world, with a thin atmosphere composed primarily of carbon dioxide. Unlike Earth's thick, oxygen-rich atmosphere, Mars's atmosphere is only about 1% as dense, providing little protection from the harsh environment of space. The planet's surface is marked by a history of volcanic activity, impact craters and wind erosion, creating a diverse and rugged terrain. Surviving on Mars presents a host of challenges. The thin atmosphere not only makes it difficult to retain heat, but it also exposes the surface to harmful cosmic and solar radiation. Unlike Earth, which has a magnetic field to deflect these rays, Mars' lack of a protective magnetosphere means that radiation levels are significantly higher, posing serious risks to human health. Temperatures on Mars can plummet to as low as -80 degrees Fahrenheit at night, while massive dust storms, sometimes engulfing the entire planet, can last for weeks, obscuring the sun and hindering solar power generation. Mars's landscape is both awe-inspiring and treacherous. Its surface is covered with fine dust, rich in iron oxide, which gives the planet its signature red colour. The terrain varies dramatically, from the towering Olympus Mons, 3 times the height of Mount Everest, to the expansive Valles Marineris, stretching over 2,500 miles long. Yet beneath this rugged beauty lies a harsh reality, an environment that is inhospitable to human life as we know it. Understanding these conditions is critical as we plan our next steps in Mars exploration. For humans to survive on Mars, we must create self-sustaining habitats capable of supporting life in an environment that is inherently hostile. The thin atmosphere means that oxygen must be generated on site, likely through processes such as electrolysis, which splits water into oxygen and hydrogen. Water, a precious resource on Mars, must be extracted from the soil or recycled from human waste and condensation. Advanced life support systems will recycle air and water, while also providing a stable supply of food through hydroponics and other innovative agricultural methods. Beyond simply surviving, scientists are exploring the possibility of making Mars more Earth-like, a process known as terraforming. This concept, while still theoretical, involves altering Mars's atmosphere and climate to support liquid water and potentially life. One idea is to release greenhouse gases into the atmosphere to create a warming effect, gradually thickening the atmosphere and raising surface temperatures. Another proposal involves redirecting asteroids to impact Mars, releasing energy and materials that could help in this transformation. While these ideas are far from being realized, they represent humanity's long-term vision for not just visiting Mars, but colonizing it. To understand the challenges of living on Mars, we can look to Earth's own extreme environments, such as Antarctica. Like Mars, Antarctica is a cold, dry desert with temperatures that can plunge well below freezing. The isolated research stations there are equipped with life support systems that recycle air and water, much like what would be required on Mars. By studying how humans survive in Antarctica, we gain valuable insights into what will be needed to sustain life on the Red Planet. Reaching Mars is only half the battle. The technology required to safely land on and explore the planet is just as critical. Propulsion systems, such as those being developed by SpaceX, aim to revolutionize space travel with reusable rockets capable of carrying large payloads to Mars and beyond. The challenge of landing on Mars, with its thin atmosphere, has led to the development of innovative techniques like the sky crane system used by NASA's Curiosity and Perseverance rovers, as well as propulsive landing systems that allow spacecraft to touch down with precision. As we push the boundaries of Mars exploration, artificial intelligence and robotics play an increasingly vital role. Today's Mars rovers are equipped with sophisticated AI systems that allow them to navigate the harsh terrain autonomously, analyze soil samples, and even make decisions about where to explore next. Future missions will likely involve a combination of human and robotic explorers, with AI-powered drones and robots assisting astronauts in everything from construction to scientific research. These technologies not only extend our reach on Mars, but also reduce the risks to human life. The journey to Mars is not just a test of human endurance, but a testament to our ingenuity and determination. With every technological innovation, we move closer to making Mars not just a destination, but a home. From advanced propulsion systems to AI-driven exploration, the tools we are developing today will lay the foundation for tomorrow's missions. As we prepare to take this giant leap, we must continue to innovate, collaborate, and dream big, because the future of humanity may very well depend on our ability to thrive on Mars. In 2021, NASA's Perseverance rover landed on Mars, heralding a new era in our exploration of the Red Planet. Perseverance is not merely another rover. It is the most advanced scientific laboratory ever sent to another world. Equipped with cutting-edge technology, its primary mission is to search for signs of ancient life and collect samples that may one day be returned to Earth. Perseverance is exploring Jezero crater, a site that scientists believe once hosted a river delta, making it a prime location to search for evidence of past microbial life. Perseverance is equipped with a suite of scientific instruments designed to analyze the Martian environment at a molecular level. For example, SHERLOC, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, uses ultraviolet lasers to detect organic compounds, while PIXL, the planetary instrument for X-ray lithochemistry, examines the chemical composition of Martian rocks. Together, these tools help scientists reconstruct Mars' history and assess its potential to have harbored life. One of the most exciting aspects of Perseverance's mission is its collaboration with Ingenuity, a small helicopter that made history as the first aircraft to achieve powered flight on another planet. Ingenuity's flights are not just a technological marvel, they also provide invaluable reconnaissance data, aiding Perseverance in navigating the rugged Martian terrain and identifying areas of scientific interest. Across the Atlantic, the European Space Agency, or ESA, is conducting its own ambitious mission to Mars. The ExoMars program, in collaboration with Russia's Roscosmos, focuses on searching for signs of life beneath the Martian surface. The mission began with the launch of the Trace Gas Orbiter in 2016, which is currently orbiting Mars, mapping its atmosphere and searching for gases that might indicate biological or geological activity. The centerpiece of the ExoMars program is the Rosalind Franklin rover, named after the pioneering scientist who contributed to the discovery of DNA structure. This rover, set to launch in the coming years, will carry a drill capable of reaching depths of up to 2 meters, far deeper than any previous mission. By analyzing these subsurface samples, scientists hope to find evidence of past or present life, protected from the harsh surface conditions of Mars. Over the years, Mars missions have made numerous discoveries suggesting that the planet was once far more hospitable to life than it is today. Evidence of ancient riverbeds, dried-up lakes and mineral deposits all point to a time when liquid water flowed across the Martian surface. These findings have fundamentally changed our understanding of Mars, transforming it from a barren desert into a planet that may have once supported life. In addition to these geological discoveries, scientists have found tantalizing hints of life in Martian meteorites that have fallen to Earth. These meteorites contain structures resembling microfossils, though their origin remains a topic of debate. While no definitive proof of life has been found on Mars, each new discovery brings us closer to answering the age-old question, are we alone in the universe? While government space agencies have led the charge in Mars exploration, the private sector is rapidly becoming a significant player. At the forefront is SpaceX, the company founded by Elon Musk, with the goal of making life multiplanetary. SpaceX's Starship, a fully reusable spacecraft, is designed to carry large numbers of people and cargo to Mars, potentially establishing a permanent human presence there. Starship represents a revolution in space travel. With its powerful Raptor engines and advanced landing capabilities, Starship is designed to make interplanetary travel more accessible and affordable. SpaceX envisions a fleet of Starships ferrying settlers, scientists and supplies to Mars, laying the groundwork for a thriving human colony. For Musk and his team, Mars is not just a destination, it's a new frontier, ripe for exploration and settlement. SpaceX's efforts are part of a broader trend in space exploration, where private companies and government agencies work together. NASA has partnered with SpaceX to deliver cargo to the International Space Station, and now these partnerships are extending to Mars. Collaborative efforts between private companies and space agencies are accelerating the timeline for Mars exploration, combining the innovation and agility of the private sector with the experience and resources of government programs. But SpaceX is not alone. Other companies, such as Blue Origin and Boeing, are developing their own spacecraft with ambitions of reaching Mars. These commercial endeavors are driving a new era of space exploration, where competition and collaboration coexist, pushing humanity further into the cosmos than ever before. The involvement of the private sector is not just about technological innovation, it's also about speed. Historically, space missions have taken years, if not decades, to plan and execute. But with companies like SpaceX at the helm, the timeline for Mars exploration is being dramatically shortened. Musk has set an ambitious goal to land humans on Mars within the next decade. While this timeline is aggressive, the rapid pace of innovation in the commercial space sector suggests that it may be achievable. As commercial space exploration continues to gather momentum, the dream of reaching Mars and establishing a human presence there is moving from the realm of science fiction to reality. The next few decades could see humanity take its first steps on another planet, beginning a new chapter in our exploration of the cosmos. One of the most critical aspects of establishing a human presence on Mars is ensuring that settlers can sustain themselves. Current research focuses on developing systems that can provide food, water and energy on the red planet. Scientists are experimenting with hydroponic and aeroponic systems that could grow food in Martian habitats using LED lighting and nutrient-rich water solutions. These systems are designed to be efficient and sustainable, using minimal resources while maximizing crop yields. Water, another essential resource, is scarce on Mars, but it does exist. Recent missions have confirmed the presence of water ice just below the surface, particularly at the poles. Engineers are developing in situ resource utilization (ISRU) technologies that could extract this water, providing a sustainable supply for drinking, agriculture and even fuel production. By splitting water into hydrogen and oxygen, future Mars settlers could generate breathable air and rocket fuel, making long-term survival on Mars feasible. Energy is another critical need, and solar power is the most viable solution for Martian colonies. Mars receives less sunlight than Earth, but solar panels can still generate enough power to run life support systems, habitats, and scientific equipment. Researchers are also exploring the potential of nuclear reactors as a reliable energy source for Martian settlements, particularly during the planet's long dust storms, which can block sunlight for weeks at a time. The journey to Mars will be the longest and most challenging voyage ever undertaken by humans. A round trip to Mars could take up to 3 years, and during that time, astronauts will face significant physical and psychological challenges. Prolonged exposure to microgravity can lead to muscle atrophy, bone loss, and cardiovascular issues. To combat these effects, astronauts will need to exercise regularly and possibly use artificial gravity environments during the journey. However, the physical challenges are only part of the equation. The psychological effects of long-term space travel, such as isolation, confinement, and distance from Earth, pose serious risks. NASA and other space agencies are conducting studies on the International Space Station to understand how astronauts cope with these stresses. Findings from these studies will be crucial in designing missions that ensure the mental well-being of Mars-bound crews. For a human colony on Mars to thrive, it must become self-sufficient, which means harnessing the planet's resources. Water, as we've seen, is vital for life support and fuel production. But Mars also has abundant mineral resources that could be used for construction, manufacturing, and even energy production. Iron, magnesium, and silica are just a few of the materials found on Mars that could be mined and processed by future settlers. Mining these resources will require advanced technology, including autonomous machines capable of operating in Mars' harsh environment. These robots could extract raw materials, which would then be processed into building materials for habitats, tools, and other necessities. By utilizing local resources, Martian colonies could reduce their dependence on Earth, paving the way for a truly self-sustaining human presence on the Red Planet. As research into sustainable living on Mars continues, the dream of a self-sufficient human colony on the Red Planet becomes increasingly tangible. It will require innovation, perseverance, and a collaborative effort between scientists, engineers, and explorers. But with each new discovery and technological breakthrough, we move closer to turning that dream into reality. The race to explore Mars has driven unprecedented technological advancements, many of which are already finding transformative applications here on Earth. The extreme conditions of the Red Planet demand innovations in energy production, robotics, and materials science. Innovations that are now revolutionizing industries far from the Martian landscape. Mars missions rely heavily on solar power, but the thin atmosphere and frequent dust storms present unique challenges. To overcome these, engineers have developed solar panels that are not only more efficient, but also resistant to the fine Martian dust that can reduce their effectiveness. These advancements are now being applied on Earth, particularly in extreme environments where traditional energy sources are scarce. From remote deserts to polar outposts, Mars-inspired solar technology is making renewable energy more viable and resilient. The autonomous systems developed for Mars exploration have redefined what's possible with robotics. On Mars, rovers must operate independently, making real-time decisions in unpredictable environments. This autonomy, combined with advanced sensors and AI, is now being integrated into Earth-based robotics. In factories, these technologies enable robots to perform complex tasks with precision, while in medicine, robotic surgery systems allow for minimally invasive procedures that were once impossible. Mars exploration is pushing the boundaries of robotics, with benefits extending across multiple sectors. Surviving on Mars requires materials that can endure extreme temperatures, radiation, and the stresses of space travel. To meet these challenges, scientists have developed new composite materials and radiation-resistant fabrics that are both lightweight and incredibly strong. These innovations are now being applied on Earth, enhancing the safety and durability of everything from skyscrapers to spacecraft, and even protective clothing for workers in hazardous environments. The demands of Mars are driving a revolution in materials science, with applications that touch every aspect of modern life. Beyond technological advancements, Mars research has also led to significant breakthroughs in other fields, including medicine. The need to monitor and maintain the health of astronauts on long-duration missions has spurred the development of telemedicine, technologies that allow doctors to diagnose and treat patients from thousands of miles away. These innovations are now being used on Earth to provide critical healthcare in remote and underserved areas, where access to medical facilities is limited. Mars-inspired medical technologies are helping to bridge the gap in global healthcare, making life-saving treatments more accessible to all. Mars research has also provided valuable insights into climate science. By studying Mars's atmosphere and climate history, scientists are gaining a deeper understanding of planetary climate systems, including Earth's. The thin atmosphere of Mars offers a unique perspective on the long-term effects of atmospheric loss and greenhouse gases, knowledge that is crucial as we grapple with climate change on our own planet. Lessons learned from Mars are helping to refine our climate models, predict future changes, and develop strategies to mitigate the impacts of global warming. The technologies and knowledge gained from Mars exploration are not just advancing our understanding of the universe, they are driving innovation across multiple fields, enhancing our ability to address the challenges we face on Earth. From sustainable energy and healthcare to climate science and beyond, the benefits of Mars research are shaping a better, more sustainable future for all of humanity. The exploration of Mars is a global endeavor, uniting the expertise, resources and aspirations of nations around the world. NASA, the European Space Agency, ESA, Russia's Roscosmos, and China's CNSA are at the forefront of this collaborative effort, each bringing unique capabilities to the table. These partnerships are not just about sharing the financial and technical burdens of space exploration, they embody the spirit of global cooperation in the pursuit of knowledge and discovery. One of the most prominent examples of international cooperation is the ExoMars program, a collaboration between ESA and Roscosmos, with support from NASA. This ambitious mission aims to search for signs of life on Mars, utilizing the best technology and expertise from across the globe. The success of such joint missions demonstrates the immense benefits of pooling resources and knowledge, enabling us to achieve more together than any one nation could alone. The quest to explore Mars has fostered a level of global unity and scientific collaboration that transcends political borders. Scientists, engineers and researchers from around the world regularly come together to share their findings, discuss challenges and plan future missions. These collaborations are not only advancing our understanding of Mars, but are also strengthening the bonds between nations, showing that when it comes to exploring the cosmos, humanity is stronger when united. As we look to the future, the colonization of Mars raises important geopolitical questions. Who will have the right to settle and exploit the resources of the Red Planet? How will nations cooperate or compete in the establishment of Martian colonies? These questions are not just theoretical, they have real implications for the future of space exploration and the role that international law will play in governing human activities on Mars. As we move closer to making Mars a second home for humanity, it is crucial that we approach these challenges with a spirit of cooperation and mutual respect. The colonization of Mars presents both opportunities and challenges on the geopolitical stage. As nations and private companies vie for a foothold on the Red Planet, the need for clear and equitable space governance becomes increasingly urgent. The development of international agreements and treaties will be essential to ensure that Mars remains a place of peaceful exploration, where the benefits of discovery are shared by all of humanity. Ultimately, the exploration of Mars offers a chance for humanity to come together in the pursuit of a common goal, one that transcends national borders and unites us in our quest to understand the universe. By fostering global cooperation and ensuring that the fruits of our exploration are shared, we can create a future where Mars becomes a symbol of unity and a beacon of hope for all of humanity. As we look ahead to the future, the colonization of Mars holds the potential to transform not only our understanding of the cosmos, but also our lives here on Earth. The technologies and systems developed to sustain life on Mars, such as closed-loop ecosystems, advanced recycling methods, and renewable energy technologies, could be adapted to address many of the pressing challenges we face on Earth. From combating climate change to ensuring food and water security, the innovations driven by our quest to colonize Mars could lead to a more sustainable and resilient future for all of humanity. The idea of Mars as a backup for humanity is both compelling and controversial. On one hand, establishing a human presence on Mars could ensure the survival of our species in the event of a global catastrophe on Earth. It represents a chance to preserve human civilization, knowledge, and culture in the face of existential threats. On the other hand, this vision raises ethical questions about our responsibilities as stewards of Earth. Should we focus on solving the problems we face here, or should we invest in building a new home in another world? The answers to these questions will shape the future of human exploration and our place in the cosmos. As we venture into the unknown, it is essential to consider the ethical implications of colonizing another planet. What responsibilities do we have to Mars, to Earth, and to future generations? How can we ensure that our actions on Mars are guided by principles of sustainability, respect, and equity? These questions are not just academic, they are central to the mission of becoming a multiplanetary species. As we look to Mars as the next giant leap, let us also reflect on our duties as caretakers of our home planet and as pioneers of a new world. The journey to Mars is a bold and audacious endeavor, one that holds the promise of new discoveries and the potential to transform our future. But as we reach for the stars, let us not forget the importance of the Earth beneath our feet. The mission to Mars is not just about exploration. It is about understanding who we are, where we come from, and where we are going. As we take this giant leap, we carry with us the hopes and dreams of all humanity, united in our quest to explore the unknown and build a better future for generations to come. Throughout history, the pursuit of space exploration has been fueled by the visionaries who dared to dream of humanity's reach beyond Earth. Their words continue to inspire the journey to Mars, a quest that embodies the drive to explore the unknown and push the boundaries of what is possible. Carl Sagan famously remarked, "The surface of Mars is the closest we will come to setting foot on another planet in our lifetimes." His words underscore the proximity and potential of Mars, a world within our reach, yet filled with mystery. Elon Musk, looking toward the future, stated, "We're going to Mars because the deeper we dig into Mars, the more likely it is that we'll find something of great value." For Musk, Mars is not just a destination, but a frontier of knowledge and opportunity that could unlock the secrets of life and humanity's future. Stephen Hawking echoed this sentiment with his belief that the long-term future of the human race must be in space. Hawking saw Mars as the first stepping stone towards ensuring humanity's survival beyond Earth. This dream of Mars is shared by today's pioneers who are actively transforming these visions into reality. Dr. Robert Zubrin, a staunch advocate for Mars exploration, once said, "Mars is the new world. It's the challenge that humanity needs to find its soul." For Zubrin, Mars represents a challenge that will test our resilience and shape our future. Ellen Stofan adds, "Exploring Mars is about pushing the boundaries of what we know and what we think we can achieve." To her, Mars is a beacon of exploration, driving humanity to expand our understanding of the universe and our place within it. These statements from the past and present leaders of space exploration remind us that the journey to Mars is not merely a physical voyage. It is a quest for knowledge, survival, and the next great leap in human history. As we have evolved from observing Mars through telescopes to sending sophisticated rovers to explore its surface, our understanding of this mysterious world has grown, revealing ancient rivers, vast canyons, and the potential for life. Today, Mars exploration stands at the brink of a new era. Missions like NASA's Perseverance rover are not just about exploration, they are about preparing for the future. The samples Perseverance collects could one day offer the first tangible evidence of life beyond Earth. Meanwhile, international cooperation involving NASA, ESA, Roscosmos and CNSA, alongside private companies like SpaceX, is accelerating the timeline for sending humans to Mars. However, the challenges of surviving on Mars are immense. The planet's extreme environmental conditions, intense radiation, freezing temperatures, a thin atmosphere, and frequent dust storms demand cutting-edge technology to sustain human life. Advancements in food, water, and energy supply, as well as the development of durable habitats, are crucial. Protecting the mental and physical health of astronauts on long-duration missions also remains a significant hurdle. As we stand on the verge of becoming an interplanetary species, the road ahead is both daunting and exhilarating. This journey to Mars represents more than just a technological achievement. It signifies a profound shift in our understanding of our place in the universe. Mars, as a new frontier for human exploration, forces us to confront existential questions. Who are we and where do we come from? As we prepare to take this giant leap, we must reflect on our responsibilities to both our home planet and the new world we seek to explore. The journey to Mars challenges us to consider what it means to be human. In becoming interplanetary, we must carry forward the best of who we are, our curiosity, ingenuity, and drive to explore, while confronting the ethical dilemmas that accompany such expansion. How will we preserve the integrity of Mars? What kind of society will we build on another planet? How will our expansion into the cosmos shape our identity as a species? These are essential questions on our journey to Mars. The mission to Mars is not just for scientists, engineers and astronauts. It is a mission for all of humanity. It embodies our collective hopes and dreams, our willingness to push beyond the known, and our determination to seek out new frontiers. But this mission requires more than just technical expertise. It demands global support and engagement. As we stand on the edge of this new era, we must come together to support space exploration and scientific research. The challenges are great, but the rewards are greater still. Mars is our next giant leap, but it is a leap that begins here on Earth. By investing in science, technology and exploration, we not only unlock the secrets of the universe, but also build a better future for all. Let us continue to dream big, explore the unknown, and reach for the stars. The journey to Mars is just beginning, and it is a journey we will take together.